Dear students, today we are going to see about our carbonyl compounds qualitative test. We know that carbonyl compounds consist of aldehyde and ketones, and we also know that aldehydes behave differently as well as ketone behave different. So when we want to identify the aldehyde and ketone functional group in a mixture or independently, we have to carry out some qualitative tests. So today we are going to see which qualitative test will be useful for identifying the aldehyde as well as ketone. So here we will include two tests which are commonly used to identify or to test or to know about aldehyde and ketone. First one is 2,4-dinitrophenylhydrazine, which is called as 2,4-DNP test. This is a test for aldehyde and ketones. Both the aldehyde and ketones can be checked or identified with this test. It is a common test, whereas second test is Chromic Acid Test, which is only exclusively to identify the aldehydes. As we know that aldehyde and ketone both are different. Aldehyde is a functional group with carbonyl group 1 hydrogen, and ketone is carbonyl group with 2 alkyl groups. So both will behave differently or react differently. That's why this test will confirm the presence of either aldehyde or ketone. So now what are the qualitative tests? So we will see that aldehyde and ketones contain the carbonyl functional group which have carbon double bond to oxygen. We also know that in the case of ketone there are two carbon atoms bounded to the carbonyl and no hydrogen is present. In the case of aldehyde, at least one hydrogen bounded to carbonyl group or carbonyl carbon is present and the other is a carbon atom or group. Now in the case of carbon that are attached to the carbonyl group may be aliphatic or aromatic or non-aromatic like that. So this is this group alkyl, this is hydrogen, it is a aldehyde group, whereas ketone both group are alkyl group or R which is contain the carbon and they cannot be replaced with the nucleophiles. Now, so aldehyde and ketone both undergo reaction types known as nucleophilic addition reactions. So it is a exclusively or it is a very well known that carbonyl compounds will not undergo the nucleophilic substitution reaction. In place of that, they will undergo addition reaction, which is nucleophilic addition reaction. Under less acidic condition, in this type of reaction, a nucleophile, which is a species that can donate a pair of electron, in other words, a Lewis base, will donate a pair of electron toward the carbonyl carbon, forming a single bond to it. So it is an addition reaction, means Lewis base attack on carbonyl group. At the same time, the double bond between the carbonyl carbon and oxygen becomes a single bond as one bonding pair is there. Same time, the oxygen now has one bond to it and it holds three pairs of unshared electrons. So it has a negative charge. Then finally, the oxygen picks up a proton from somewhere or possibly from the attached nucleophile atom attached to the carbonyl carbon and becomes an OH group. So here this nucleophile attached to the carbonyl and O minus will form. Then the protonation takes place and we will get the addition product where nucleophile attached to carbon and O attached to hydrogen. Now the first test to identify the carbonyl group presence in a mixture or unknown compound is a 2,4-dinitrophenylhydrazine test, which is also called as short form 2,4-DNP test. This test is common for both to identify the aldehydes and ketone. Means these reactions will be given by both aldehyde and ketone. So it is a primary test to confirm the presence of carbonyl group in the mixture. Now carbonyl group may be aldehyde or ketone. So when both aldehyde and ketones will react with a number of nitrogen containing compounds, So nucleophilic addition and subsequent loss of water to give reaction product that have a carbon-nitrogen double bond. These reactions are useful in distinguishing aldehyde and ketones from other functional groups, but cannot be used to distinguish between aldehyde and ketone. So this reaction is only useful to identify the carbonyl functional group from other functional group, but it will not useful to identify aldehyde or ketones. 2,4-dinitrophenylhydrazine can be used to quantitatively detect the carbonyl functionality of an aldehyde or ketone functional group. So, if a positive test signaled by a yellow or red precipitate known as 2,4-dinitrophenylhydrazine confirm the presence of carbonyl group. So, if you see the chemical reaction of these compounds, in this what happened? Either aldehyde or ketone will react with this hydrazine 2,4-dinitrophenylhydrazine. This hydrazine will undergo dehydration and will give this hydrazone C double bond N compound. This is either orange red color or yellow color. So the formation of this red or orange precipitate or yellow precipitate confirm the presence of carbonyl group in 2,4-DNP test. Now, if you see the thing in these reactions, simply cyclohexanone, benzophenone and benzaldehydes undergo this reaction. Now, what is the procedure of this reaction? So, add a solution of 1 or 2 drop of 30 mg of unknown, 2 ml 95% ethanol of to 3 ml of 2,4-DNP. So, solution of your compound, either aldehyde or ketone, and take that 2 or 4-DNP and shake vigorously. It precipitate and form a solid red or orange solid. So, this simple addition of this thing gives you the hydrogen formation. The formation of a precipitate is a positive test, means it confirms the presence of either cyclohexanone, benzophenone, benzaldehyde or any aldehyde or ketone. Now there are complications also there. Sometimes what happens, some ketones gives oil which will not solidify. So now if you go to the higher carbonyl compounds, they will not give the solids, but they will give the colored oily compounds. This is a limitation. Because some allylic alcohols are oxidized by the reagent aldehyde and ketone to give a positive test. So some alcohol also undergo oxidation and they give a positive test. So there are some limitations. So in this thing, the allylic alcohol cannot be used. Some alcohols, if not purified, may contain aldehyde or ketone. They also give a positive test. However, the 2,4-DNP test itself is a orange-red color. Thus, the color must be judged with the very carefulness. Means, if reaction is not going, the orange color will come. So, orange color is not an indication. It is a solid precipitation should be made. Now, if you see the reaction mechanism, what is happening? In the first step, this hydrazine amine nitrogen will attack on the carbonyl carbon as a nucleophile, and the electron will move to the oxygen and it will convert into the negative charge oxide ion. In the next step, what happens? This oxygen will take the proton from the amine, hydrazine amine, and elimination of this thing, and we will get this product, which is a intermediate. Then finally, this deprotonation will take place, and we will get the hydrazone formation, elimination of water. OH from here and hydrogen from here, elimination of water. So it is a actually addition, condensation and elimination reaction. 3 reactions is taking place. So in the first step, this compound is formed. In the second step, the elimination of water take place, OH via protonation. This OH will take proton and then elimination will take place and water eliminated. Then in the last step, what happened? This proton will be absorbed by water and we will get the hydroxonium ion and elimination will take place and we will get this imine type of hydrazone compound. Now, the second test, which is a chromic acid test for aldehyde. So we are very well known that aldehydes are the functional group which undergo oxidation to give carboxylic acid. And we very well know that chromic acid is an oxidizing agent. So by reacting with chromic acid, if any aldehyde is there, it will convert into corresponding acid. So the formation of reaction of chromic acid with aldehyde to form the acid is a confirmative test to presence of aldehyde. So these reactions are usually referred to as a nucleophilic addition reaction. Aldehydes are oxidized by chromic acid, ketones are not. So in this reaction, the ketones are not formed. So it is a test to identify the aldehyde from ketone or segregate from ketone to aldehyde. So first test, 2,4-DNP test, is to identify the carbonyl group, either aldehyde or ketone. The second test is a confirmative test, which is a chromic acid test. It is confirm the presence of aldehyde, not the ketone. When an aldehyde is oxidized by orange-brown chromic acid, the chromic acid is reduced to chromium ion, which is green. Consequently or subsequently, chromic acid can distinguish between aldehyde and ketones. It is also true that the functional group, primary and secondary alcohols, for example, can be oxidized by chromic acid, causing the formation of a green color. But we have to be very careful. Now, what is the procedure for this reaction? So, dissolve 10 mg or 2 drops of unknown compound in 1 ml of pure acetone in a test tube and add to the solution of 1 drop of Jones reagent or chromic acid in sulfuric acid. So, chromic acid test is reagent, also known as reagent, which is a Jones reagent. It is a chromic acid in sulfuric acid. It is an oxidizing agent. A positive test for this marked by the formation of a green color within 5 seconds. So what is happening here? Aldehyde will undergo oxidation to give the carboxylic acid and chromium sulfate and water. So the formation of green color itself shows the presence of carbonyl group, particularly aldehyde. So with this, today we have completed the confirmation or qualitative test for the carbonyl compounds. In this, we have seen two tests. One is a 2,4-DNP and another is a chromic acid test. Thank you very much. We will see you in the next class.